Okay, now we're going to talk about the sine, the cosine, tangent, and the cotangent in a right angled triangle. Okay, you just say I draw a triangle with a right angle. We got a side A with an angle alpha and B with an angle beta. So the general formula stipulates that the sine of theta is normally the opposite, it's the opposite side over the hypotenuse, right? The cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. And the cotangent, it's also it's the opposite, the inverse of the tangent. It means that it's gonna be the adjacent over the hypotenuse. This is but a general formula. In fact, when you are just like consider an angle like here at alpha, the opposite side will be b. But if you consider b to be an angle, the opposite side will be a. And as you can see here, I've chosen two different colors, a green and a blue. That means that we're gonna have two cases, to give the different opportunity. The different possibility of solving out the sine or the cosine, the tan, and the cotangent or an angle. It all depends on where you are standing, where you are making your choice, or you're taking your angle. Okay. So in case one, according to this general formula here, we will have the sine. Okay, so we're talking about the sine of alpha here. So the sine of an angle is the opposite side over the hypotenuse. So the sine here of this angle here is normally the opposite side. It is b here, right here. It is b over the hypotenuse, and the hypotenuse, oh, I forgot to put it. It's c, right? So we can put c right here. And the cosine of the angle is the adjacent side over the hypotenuse. So the adjacent side of alpha is of course a, right? So we're gonna have here a over the hypotenuse. And now we know that the tangent or the tan is the sine over the cosine. In other words, the opposite side over the adjacent side. So that's gonna give us here the opposite side of alpha is b, and the adjacent side of alpha is a. So we're gonna have here we're gonna have here what do we say? B over a. Okay, or you can even divide this both fraction. The c will cancel out, so you're gonna have b over a, and the cotan is the inverse of the tan, so that would definitely give us a over b. So that's when you are considering, you've chosen your angle to be alpha. That's how you can look. You can see a thing in this angle right here. But now, what about the case two? We're now here, and our angle is beta. So we want to find the sine of this angle, the cosine, the tan, and the cotan of this angle. So when you stand here, the opposite side is a in this case. All right. So the sine is opposite over the hypotenuse. So we're gonna say that the sine of our angle beta here will be a over the hypotenuse c. A over c, of course. And the cosine of our angle will be the adjacent side over the hypotenuse. So the hypotenuse is c, and the adjacent is b. And the tan right here will be the opposite over the adjacent. The adjacent is b, and the opposite is a. Just like we did here, just like I told you here, you can only take this sine divided by cosine, and then you're gonna have this a over b when the c cancel out. And the cotan is the opposite, so we're gonna have a and b over a. As you can see, determining the angle, the sine, the cosine, and so on of an angle it's all it's all about the angle you've chosen. Because if you, it all depends on where you are standing, right? So you got to be careful to know that if you got an angle, okay, this is the angle. I mean, your angle is going to be considered, and at that position, that's where you're going to be rating the other component of a right angle triangle, right? Just like we've seen here in case one, we're standing here and everything's happening like B is the opposite side. And but by the contrary, if you were here, if you stand here, A would be the opposite side of your triangle, or your right angle triangle, right? And of course, as these two angles, alpha and beta, are opposite to each other, you can see how everything, the sine and cosine interact, inverse in each other. You got like the cosine, the sine of B of alpha will be the cosine of B. See, and the cosine of alpha is the sine of B. Using the opposite, and the tan of alpha will be the cotan of beta, where the cotan of beta or alpha is the tan of beta. So this is how it works. So once you got an angle, you can even just take like an inverse or the other one for the cosine and the sine, or tan or cotan. Then you have everything. So now, as a reminder, now we know that we're dealing here with the right angle triangle. So it means that we can use some rules of Pythagoras here. That is, this is equal to C2. Pythagoras said that the length side, the hypotenuse to the two, is equal to the sum of the two other sides squared. Okay, C squared equals to A squared plus B squared. That's how it's squared. So you got to make sure that you're working with the right triangle to use this formula here, and this is a Pythagoras. Okay, so now we're going to take some little example where we're having like we're having an angle. We're having an angle. Sorry, got a square there. Okay, we're having A given. It is 12.7. Okay, 12.7 centimeters, and we're having C given equals to 24.9 centimeters. And here, of course, in the right angle, because you can call it, like a gamma or something like that. It's a 90 degree. That's not a problem, because we said before that we are in a right angle triangle. Now, what we're looking for here are B. Of course, we don't have B. We're looking for alpha, the angle. Okay, one of the angle, and we're looking to beta also, the other angle. So how to do that? First of all, you can notice here that we have A and C. All right. So A and C, it means that we can use the Pythagoras rule to find it straight. So we're gonna say we know that B to the power 2 equals to, when you subtract minus A to the power 2 here, or A squared, it's gonna give you B squared equals to C squared minus A squared. So you can square root it, right? And by square rooting it, you have B equals to the square root of C to the 2 minus A to the 2, and we just need to replace the value here to have the answer. And this is going to give us, if you put in the calculator, it's going to give us 21.41 centimeters. Alright, that's B. Let me take a different color. That's B. Okay, and now we need to have our two other angles, alpha and beta. We can say that the sine, we can even need the cosine, right? The sine of alpha equals to, that's what we said here, the sine of this angle equals to B over C. Do we have B? Yes, that's what we find now. And do we have C? Of course. So this is going to give us 21.41 centimeters over what is that? C 24, okay, 0.9 centimeter, and this is 0.86. And as we're looking for alpha here, we got to isolate it, so to separate it from sine. This is going to mean that alpha itself is the sine, the opposite sine or the arc sine of 0.86, right? And this is going to give us 59.3 degrees. Now we're looking for b, and we're going to say, let us just see the tan here. We're going to say the tan of beta, sorry, we're looking for beta, of course. The tan of beta is equal to, we say the tan was the opposite over the adjacent. So the tan will be here a over b. And what do a is 12.7 centimeters over b, and b is what we found before, 1 centimeters, right? So, and this is here 0.59, right? And as we did here, what was that here? We're going to say that beta equals to 10 minus 1, and 10 minus 1 is the arc tan of 0.59, okay? And that's going to give us an angle of 30.67 degree, and that's how we have beta. We've already have alpha here. Okay. Sorry. To make a proof of that everything, all you need is to add, because we first know that the sum of all the angle of a triangle is 180. So what you can do here is to add, all the angle we have together to 90 and see what it gives us. So we have a 90 plus 59.3 plus 30.67. So this is going to give us, we put in the calculator, something like 179.97. Okay, if you round it up here, of course, going to give you something like an average of 180 degrees. So we know that our triangle, the angle we found are, at least correct, but are justifying the value we wanted to have. Okay. But anyway, it doesn't matter what value we're gonna have here. This is your degree. Okay. The only thing to do is that if you have, these if you're working with a right angle, you have to make sure that you can use, if you have the like a point of it, or like a side given, you can make sure that you can use the Pythagoras rule. And using this general formula or everything here, you can just, this is a general one, but by defining or determining your angle, all depends on what position you occupy on the triangle. If you stand here, of course, your results going to be a little bit different. If you stand there, it's going to be a little bit different. Okay, and as we're saying, these both angles are opposite to each other, so their value from the sine to the cosine are the same. All right. Okay. Thank you for watching again. Until next time. Bye bye.